Hi everyone, in this video we are going to learn about the examples of the conjugates. What is the benefits of the conjugates of the complex numbers. We already discussed about the conjugates of the complex numbers. I will share the link of the video in the description box. First check that video, then you can easily understand this problem. Here the question is, let's discuss about these questions. The question is finding the multiplicative inverse of the given complex number. Find multiplicative inverse of the given complex number 4, 7. It is divided by the another complex number 2, minus 3. We already discussed about the methods for finding the multiplicative inverse of the given complex numbers. We already make the separate video on that topics also, but here we are going to solve that problem in a short way by using the concept of the conjugate of the complex number. And if we use the concept of the conjugates of the complex numbers, then the problem will be solved in a very short time. It will be very short in the solution. Please remember that an important point on the multiplicative inverse of any numbers. If we multiply a number and its multiplicative inverse together, then the result will be always 1. The product of the number and its multiplicative inverse always gives 1. Let us suppose the given complex numbers here is a z. It is here 4, 7 in the order pair format. It is divided by 2, minus 3. And this can be written as in the linear form 7i. It is divided by the complex number 2 minus 3i. And we already know that the product of a number with its conjugate, with its multiplicative inverse, always gives the value 1. Please remember this point. The product of a numbers with its multiplicative inverse always gives the value 1. Let us suppose z raised to power negative 1 is the multiplicative inverse. Let z raised to negative 1 is the multiplicative inverse of the complex number z. So by using this statement, the product will be always 1. Therefore, the product of the complex numbers and the multiplicative of it, which is denoted by z raised to negative 1, the product is always 1. Therefore, the value of the z raised to negative 1, which is the multiplicative inverse of z, doing the cross multiplication here, the result transposing z, this z to the right hand sides, and this will be the divisor 1 over z. Now substituting the values, we have the value for the z here. This is 1 divided by the value of the z is here given this 4 plus 7i, and it is further divided by 2 minus 3i. Now using the concept of the fractions, this part 2 minus 3i goes in the numerator sections by using the concept of the fractions. This can be written as 2 minus 3i. It is divided by 4 plus 7i. Now doing the divisions here. Here are the two complex numbers in the division format. So doing the divisions, and we already made the separate video on the divisions of the complex numbers also. Here I am going to use the short method for the divisions. Here the divisions can be performed by using the concept of the conjugates of the complex numbers. This can be written as 2 minus 3i, it is divided by 4 plus 7i. If we multiply both the numerator and the denominator by the complex conjugates of 4 plus 7i, then the result will be this 4 minus 7i times 4 minus 7i. Here in this step we multiply both the numerator and the denominator by the complex conjugates of this denominator 4 plus 7i. 4 minus 7i is the conjugates of 4 plus 7i. Here we do the multiplication. The benefits is here. The benefits here in denominator format, there is a format like a plus b times a minus b, and we can directly use the concept of the squares of the difference of the squares. Now doing the calculations here, 2 minus 3i times, here multiplying the fractions 4 minus 7i in denominator, there is a form like a plus b times a minus b, which has the formula a square minus b square. Now solving this can be written as here in numerator multiplying the two complex numbers. Let's do the multiplications directly here. 2 times 4 gives 8, and the plus times minus gives minus, and the 2 times 7 gives 14i. Here directly minus 12i, and this negative times negative is positive, and the 3 times 7 gives 21, I times I gives I square. This is the result of the multiplications of these two complex numbers in the numerator, and here in denominator 4 square gives 16 minus 7 square is 49, and the I square gives negative 1. So this will be plus. Here in denominator the result is real numbers, and division of a complex number by the real number is very easy to calculate. Here in numerator collecting the like terms here, and this is the I square is negative 1, so this will be negative 21. Here negative. Now in numerator collecting the like terms here, plus 8, and this is I square gives negative 1, so this will be negative 21, and here minus 14i minus 12i, so adding negative 26i, and it is divided by these numbers. 49 plus 16 gives 65. Now this will be negative 13 negative 26i, it is divided by 65. Now distributing the denominator, common denominator, minus 13 divided by 65, negative 26 divided by 65i. Here we do the divisions. Here the divisions of the complex numbers by using the concept of the conjugates of the complex number, which will be very short. Here in this system the value of the I square is taken as a negative 1. Therefore the value of the z raised to power negative 1 is here often minus 13 divided by 65 minus 26 divided by 65i, which can be written in the order pair format, negative 13 divided by 65 comma negative 26 divided by 65. Here we calculate the multiplicative inverse of the given complex number z by using the concept of the complex conjugate. It is very easiest way for finding the multiplicative inverse of any complex numbers and divisions of the complex number by the complex numbers. Please keep watching, please keep loving this channel, and this much for today. Thank you.